Moment of inertia. Moment of inertia in general is noticed by I. Here for your classes, we don't need to take the moment of inertia in details. Just some notes we take. The general relation of the moment of inertia will be I equals to I cm plus m d square. Okay, here for any object, for example, here let's say we have a road, this road, or if we have a sphere, if we have a cylinder, for any object, we have the moment of inertia of the center of mass, ICM, plus md square. Let me explain each point, what I mean by ICM and md square. ICM for any object must be given, okay? For example, here we have a table. For example, in the case of a empty cylindrical shell, or thin cylindrical shell, ICM equals to mr square. R is the radius. It's a thin cylindrical shell, so the thickness is negligible. Okay? In the case of a hollow cylinder, we have internal and external cylinder. ICM is given also, and so on. In the case of a solid cylinder or disk, I give you ICM. In the case of a rectangular plate, I give you ICM. In the case of a long, thin rod, also I give you ICM. For the sphere, for the thin spherical shell, and so on. Anyway, you have to know, in general, ICM is given. Okay? ICM, it's a given value. It depends to the mass of the object times the radius of the object of any regular shape, as you see here. Second, we have IDM, okay? We have mr square. So about ICM, I give you its value. But what is md square? Let's say, for example, we have a disk, no black, blue, it's good. This disk, here we have to take an axis can pass at the center here, so we get a rotation, simple rotation, and also the axe can be at any point. For example, if the axe is at this point, so we get a rotation about the axe, okay? So here the center will rotate about the axe. This point will rotate about the axe. This point, look, we can say simply, for example, if the axe is at this point, the axis, in this case, any point, for example, this point will turn like this, okay, about the axis. And also, let's say this point here will turn also about the axis. Any point, anyway, the whole object will turn about the axis. Let's say we have the sphere and we have the axe at this point, or it's a disk, the axis is at this point. You know, for any object, we have the center of mass. The center of mass of this object will be at the center, at this point, center of mass. M is the mass of the object. D is the distance between the axis and the center of mass. D. So we can say here simply D is the distance between the axis and the center of mass of the object. Okay, so ICM is given. In the case of disk, we have ICM equals to where's the disk? It's here. Equals to half mr square. Okay, so we can say here, in the case of disk, we have ICM is given equals to half mr square. R is the radius of the object. Here we have R. So we can say finally I equals to ICM plus M times D square. Okay, this is the answer. Let's take another example. We have this disk and we have the axe passes through the center. You know, before here we have the center of mass. The center of mass is at this point, and I give you also here we have the axis, okay, at the same position. So here we have a rotation. So the moment of inertia of the system equals to I Cm plus md square. You know, the distance between the axis and the center of mass equal to 0. So we can say here directly I equals to ICM equals to m over 2 r square plus 0. So here we have I equals to m over 2 r square. Let's take another example. If we take a road, for example, this one, the x is at this point. Here we have the axis. And you know the center of mass of this road is at the midpoint. So the moment of inertia of this one equals to I of the center of mass plus md square. D is the distance between the center of mass and the axis. And ICM in the case of a road. Here we have a road. What is the difference here? I take, yes, center of mass, ICM. Here we don't have ICM, okay? Here I give you I total. If we have the X passing at the edge of the road, like our case, we must have this result now. Here, I equals to ICM plus md square equals to 1 over 3 ml square. Okay. Anyway, now I want I of the road equals to 1 over 12 ml square. Okay. So we can say I equals to ICM ml square. You know L is the length of the road, plus m times d square. D is the distance between CM and axis. So simply it's easy. Here, if we have the axis at the center, we can say simply we put the x here. So in this case, d equals to 0. Okay, it's simple. Now, I have also one example. For example, if we have this road and we have many objects uh, on this road. For example, let's say we have M1 and we have let's say we have M2 here and M3. Okay, so here we have many objects. We have object ball 1, we have 2, we have 3, and we have the road. In this case, I give you the x at this point. Okay, so all the system will turn like this, here like this one will turn like this, the road will go down, and this one will be is fixed. Okay, we get a rotation about the axis. Okay, now let's calculate the total moment of inertia of the system. You know, for the block 1, the center of mass is here. The center of mass, let's take here, let's say here. Here we have the axis of all the system, and here also we have center of mass of the object 1. For the object 2, here we have the center of mass of the object 2, and also here we have the center of mass of the third object. And here at the midpoint of the road, we have the center of mass of the road. Okay. The total moment of inertia equals to the moment of inertia of the first one plus the second one plus the third one plus the road. Okay, each one equals to ICM1 plus M1 D1 square. For M2, we have ICM2 plus M2 D2 square. Also the same for this one. ICM for the road plus M of the road. Let's say we have small m of the road times d square. Okay, I give you here if the object or if the axis, we can say in general C ICM ICM is equal, or ICM equals to 0 if the axis uh, doesn't pass through the object. It's very important. What I mean here, the axis is at this point. Look, it's here, the axis. The axis is passing through the ball 1. So we have ICM. Let's see what is the value of ICM of a sphere. It's a sphere. ICM of a solid sphere equals to 2 over 5 mr square. ICM of sphere okay. So let's say here we have the sphere here with a radius r1. Okay, so I1 equals to ICM1. It means it's 2 over 5 times M1 R1 square plus M1 D1 is the distance between M1, the center of mass of 1, and the axis, equal to 0. Okay, so times 0. So here we get only this term. Let's take the object 2. The axis is not passing through the object 2. In this case, we don't have ICM. The same for the object 3. The axis is not passing through this object 3. We can say ICM equals to 0. Here we have the road. The axis is passing at the edge of the road, so we have ICM of the road. So I2 equals to M2 times D2 square. D2 is the distance between the axes. Let's say here between the axes and M2. This one is D2, which is equal, for example, okay, anyway, maybe I give you, for example, the distance between this point and this point. For example, we have x1, for example, and here we have half L, okay? The total length is L. Here we have L over 2, for example. In this case, D2 equals to x1 plus L over 2, okay? It depends the problem. Anyway, we can keep it like this. D3 equals to the distance between the center of this sphere and the axis, equals to L from this point to this point. So in this case here we can say M3 times L square. About the road, you know ICM of the road equals to 1 over 12 M L square. M is the mass of the road. L is the length of the road, plus M of the road times the distance between D, between the center of mass of the road and the axis, equals to L over 2. Okay, it's D. So here we have L over 2. And then 2. Okay, it's D. So here we have L over 2. In this case, we can say finally, I total equals to I1, 2 over 5, M1, R1 square. R is the radius of the ball 1, plus I2 equals to M2 D2 square. I3 equals to M3 L square, plus I of the road equals to 1 over 12 MR L square plus MR L over 2
square.
Okay, like this we can solve and we can calculate the moment of inertia of any object, any complicated object.